So radians, we're going to be finding the length of an arc today, so hit pause, make some notes. When you're ready, hit play again. So when we're working in radians, it's much easier to find the length of an arc. Now, I don't know if you recall finding the length of an arc in GCSE, I'm sure you do. Let's draw our circle first. So there's our circle, radius r. We'll need another radius to show the length of the arc that we're trying to find. So that's L there. And that L is subtended by an angle here, an angle of theta. Now, when you did GCSE, as I'm sure you recall, we looked at theta as a proportion of the whole circle. So to find the length of the arc L, we would say that L is equal to theta divided by 360 times the circumference of the circle, which is 2 pi r. And we worked it out that way. Okay, we're not going to be working it out that way today, so we can get rid of that. It's much easier if we look at the ratio of the length of the arc we're trying to find divided by the entire circle, so the circumference of the circle, and that's equal to the length of an arc. The angle that it subtends is theta, and the circumference of a circle is 360 degrees. But in radians, that is, yep, correct, 2 pi. So length of the arc is L, circumference of a circle, 2 pi r, that's equal to theta over 2 pi. So to find L, or to get L on its own, we say that's equal to theta divided by 2 pi times, and that is divide on this side, so it's multiply on the other side, the opposite, times 2 pi r. We can cancel the 2 pi's. I'm just going to change to a blue pen. So cancel the 2 pi, top and bottom cancel, and if I go back to red, we have L is equal to theta times r, and that is the formula for finding the length of arc. Now theta must be in radians, so we have to have theta must be in radians. Good, so hit pause, make some notes. You don't have to learn the proof, but you do have to know that L equals theta times r, the radius. And when you're ready, we'll look at an example. Okay, our first example, we've got to find the length of the arc of a circle with radius 5.2 centimeters. The arc subtends an angle of 0.8 radians at the center of the circle. So we use our formula. L equals r theta. The radius is 5.2 times the angle 0.8. When we work that out, it's going to give us 4.16 centimeters. And it's that simple. The length is 4.16 centimeters. Job done. So hit pause, make some notes, and let's have a look at another example. Okay, so in this example then, we've got an arc AB of a circle, center 0, and radius r subtends an angle theta radians at the center. Perimeter of the sector is p centimeters, and we want to express r in terms of p and theta. So this kind of a question, it really pays us to sketch it, because we've got quite a lot of information in that paragraph. So if we sketch our circle then, like so, and we draw the two radius that generate that length of arc AB. Now AB is subtended by the angle theta at the center of the circle. There we go. So that's our sketch. Now the perimeter of the sector is this section here plus the arc plus the other radius there. So that's the perimeter we're looking at. Now we know this section is the length of the arc, the radius here, and we know the radius here. The length of the arc though, so we can say the length of arc AB That's going to be equal to r theta. It's that simple. And the perimeter, P, is equal to the length of the arc plus 2 radius, so 2r. Length of the arc is r theta plus 2r. So P is equal to r plus 2r. Now they want us to express r in terms of P and theta. That means we've got to make r the subject. So we want to get r on its own. That means P is going to be equal to, if we factorize that, we've got r theta plus 2. So r is going to be equal to P divided by theta plus 2. And that's our solution. So we've got r in terms of P and theta. So hit pause, make some notes. When you're ready, we'll look at another example then. Okay, for this example, we've got to find the border. Well, the border of a garden pond consists of a straight edge, AB, which you can see is 2.4 meters, and then a curved part C. You can see from the diagram. Now, the curved part is an arc of a circle, center O, and radius 2 meters. Find the length of C. So we've got to find the length of C. In order to find the length of C, we can use our formula, r theta. We know what the radius is, but we don't know what theta is. So we need to find what is the angle theta. If we work out the angle theta, then we're okay. Now, we've got enough information here in this triangle to work the angle out. We've got the length of the sides, 2 meters, and we've got this length here. Now we can use SOHCAHTOA for right angle triangles. So if we recreate that triangle here, let's just sketch it. So there's our triangle. The radius is 2 meters, and this length here is 2.4 meters. Now if I drop a line down here, then I end up with a right angle triangle, which is great, because now if I call this x, the angle x, I can call this is 1.2 because it's halfway, and that's also 1.2. Now I know that's 1.2. The hypotenuse is 2 meters. I've got a right angle triangle. I can find x using SOHCAHTOA. And I've got, in relation to x, I know the opposite on the hypotenuse, which is sine. So sine of x is equal to opposite, 1.2 divided by 2. So sine of x is equal to 0.6. And so x is going to be equal to, using your calculator in radians, sine to the minus 1 of x. So sine to the minus 1 of 0.6, and that's going to be equal to, what have we got? 0.6435. There you go. So that's x. But remember, that's only half of the angle we're looking for. The whole angle is going to be 2x, because there's also x here. They're identical triangles. So 2x is going to be equal to 2 times 0.6435, which will give me 1.287. Let's not forget, these are in radians, and I should be putting my little radian sign there. So 2x equals 1.287 radians. So that's this angle here. Now theta is on the outside. So theta is going to be equal to the whole angle all the way around the circle. So the entire angle, which is 2 pi, minus that 1.287. When I work that on the calculator, 2 times pi minus 1.287, I should have 4.996 radians. and that's theta. Now I know theta, I can work out my my arc, because the length of the arc, L, is equal to r, radius, times theta. Radius is 2 times 4.996 radians. That gives me 9.99 radians. So that's the length of C as required in the question. So hit pause, make some notes, and I know you're itching to attempt some questions, so we can get straight into that. Just one more thing before we move on. Can you make sure when we're working out the angle X, make sure your calculator is in radians, as we said before. So make sure you this shift setup, just doing it now, and then angle unit is 2, so hit 2, and then degree, radians or gradients are given, and radians is number 2, so hit 2, and that puts your calculator into radians then. Good. Let's look at some questions then. And we're going to do exercise 5C. Question 1, they are all different. So you've got to find length, then the radius, then theta. You could possibly do the left hand side, but if you're unsure, attempt more of the other questions, and then you can go on to quite a few questions here, but they are quite quick once you get into them, and it takes you up to question 14 then. Good luck. It's page 120, exercise 5C.